With Mark from Leader Chuck Systems, straight away I'm thinking with you guys, work holding, clamps, vices, etc. But this looks slightly different. What is it?
It's an ice plate or an ice chuck. We clamp products on here with the use of ice. So we put a few drops of water on there, whatever product we want to grip, place on top of the water, press the product down to expel the water from underneath. That way we know that the product is down on a ground face, so we know exactly where it is. We've zeroed it. By pressing it down, the water is now lapping around the periphery or the contour, the outer contour of the workpiece that we're going to hold. Okay. Air, just regular shock.
Standard airline.
A standard airline is used to activate the ice clamp, yes.
Now you mentioned this, I mean, this expensive fluid to actually do the clamping?
Yeah, it's composition, it's a chemical composition called H2O.
All right, so basically water. Tap water?
Tap water, yes.
Simple as that, simple as that. So no special, so air, everybody, energy's going to have.
So it's the elements, isn't it?
Oh,
you know, it's,
nice and easy. And to get it off, we need fire.
No, yeah. So what's happening now is the plate is dropping in temperature to minus below 0 Celsius. You will notice that what will happen is the plate will sort of bloom as it reaches a critical point where the frost is there.
Yeah. So when you see the bloom, you know it's locked in place.
Absolutely, you know it's locked in place.
Okay, so what sort of materials, Mark?
Right, materials that we use to clamp on these ice are materials that can't be held on a magnetic chuck, for example. Materials that can't be held on a vacuum chuck because perhaps of their porosity. Materials like plastics and the lenses, for example, that go in intraocular lenses.
Easy for you to say.
These are ground on these plates before they're inserted into the rear of the patient's eye.
Oh, okay. Well, hopefully we won't get to see that. But so, Mark, what sort of clamping force is this giving?
Well, when you talk about clamping forces that you might measure in a chuck or a vice, there's no clamping force. That workpiece on there has no stress applied to it whatsoever. It's simply held in place by being surrounded by ice.
With ice.
Can I ask you to try and take it off now?
Yeah, I've been down the gym this morning.
I'll turn the air off.
I've been down the gym this morning, Mark, so that's coming off. No, it's not, is it?
Bang it!
That's definitely not coming off. So, right. Materials we've done. What sort of industries and components are you looking to machine on there?
Ceramics is a big market for this, where people want to hold and grind ceramics. Great way to hold them. Plastics. That's the next best industry that we sell to.
Okay, I'm thinking smaller components because of the size of the table. Well, call it a table.
Well, what we have here, I mean, because it's run on a regular airline, the bigger the table, the less efficient the freezing will become. So with the biggest plate we do is 250 millimeters. If you have workpieces that are bigger, then we use modular plates. So you can so long as each of them has an airline feed, they'll all freeze together.
So there's no real limit in terms of size of component, but it's more aimed at the smaller components. Horology, for example.
Yeah. Horology would be an industry where we could certainly use this, and it is sold in numbers in Switzerland.
Okay. Yeah. So. Sounds very simple, but a quick summary of the ice vice, please, Mark.
For holding difficult to hold material whilst you grind or mill them quickly. You have to do it quickly, of course, because you're going to transfer heat into the part. Okay. But that's it.
Yep. And nice and simple in terms of special equipment, airline and water.
Airline and water. There you are.
Mark, thank you very much.
Thanks, Colin.